Hey guys, welcome back to the Moveable demo. If you're just joining us from the previous demo, go ahead and make sure that you've made a copy of your previous map. If everything is lit up already, good. We're going to be editing our stationary file to create our own movable setup. And this should only take about 10 or 15 minutes. And then I'm going to be able to demonstrate a few more elements here. We're going to talk about DFAO, we're going to talk about distance field shadows, but we're also going to talk about them in the context of baked lighting and also with lumen. So just keep that in mind. I'm looking over here at my notes for you guys who see me looking off. And also we're going to cover a nighttime lighting scenario. So as long as you guys understand more or less where we're starting from, we should be good to go. Alright, so let's go ahead and get started. In order to get started here, as you can see, I believe it's going to be angry and it's going to give us some preview lighting because, again, we made a new map, but we didn't bake on this new map. All we did was we copied our previous map and we called this CS Moveable. Let's go ahead and tear a few things out of this that we don't need in order for this to be a fully movable setup. Now, movable means dynamic lighting, dynamic pre-lumen lighting, meaning no lumen lighting. Let's go ahead and select our light mass importance volume, and I'm going to delete that. I'm going to keep the sphere capture actors, but I'm going to go ahead and move them into my folder here. So I've got them selected here, and I'm just going to move them. There's so much bad level management on this level. Let's see, I might have to just forget that for now. Let's see if I can. You know, I'm going to leave them for now, although I probably should have put them in a folder. The organization for a lot of what's happening in this level is not actually conducive for file management here. I'm trying to manage a file that I didn't manage from the onset, which kind of makes this difficult to work with. I'm not going to merge these together. I'm going to. There we go. I'm going to move them into my Light FX folder. There we go. Now they should be in there. Yep, there they are. Alright, that makes my life a little bit easier. Now those will still work within reason. I might want to get rid of them if they're not going to be giving me any kind of dynamic lighting because they still have a cost. But fundamentally, you should be fine with them anyways. Now I'm back in the scene here because we don't need to do any kind of file management in this particular demo, but if I start to, I'm going to disable the camera so that everybody has an opportunity to see what's happening in my file. I'm going to go ahead and select my directional light, and I'm going to change it to movable. I'm going to change my nighttime, or excuse me, nighttime, my skylight to movable as well. Cool. My exponential height fog by default is already movable because it is moving in the scene, but it's not a light, so I don't need to worry about that. And my reflections don't have mobility because that's not how they work. Okay. So we're about 90% of the way done with our real-time light. I'm going to go ahead and go into World Settings, and I'm going to click Force No Pre-Computed Lighting. As you can see, this is asking me, hey, this is enabled. Now, let me do this initially. I'm going to do a bake here. Let's say I'm going to set up a scenario like you guys. I'm going to set this up to stationary, and I'm going to do a quick lighting bake. So I'm going to explain what happens if you're switching from a scenario where you have lights that are baked to lights that are movable. So I'm going to let this cook down, and I'll be right back. Alright, I'm back, and as you can see, it's giving me issues. It's giving me grief about no importance volume found. That's fine. If we go back into our world settings, we see that it's generating a light map. Oh no, I forgot to change a light over into fully movable. Okay, that's fixed, right? Remember what I said last week, about baked lights and then changing mobility? That you have to do a rebake? The lighting that we're seeing right now is not indicative of a situation where our light is correctly unbaked. If we get rid of these two, we see that we haven't done fully a complete bake, but our lights are not going to be 100% accurate because we do have some light maps. We absolutely have some light maps. And that's going to make things a little bit more difficult for us to work with if we have light maps that aren't supposed to be used. So let's go ahead, and I'm going to go to the light map settings here, and I'm going to turn on force no pre-computed shadows, or force no pre-computed lighting, and I'm going to do a build. It's going to fail right out of the box. See, it didn't build. I'm going to do another build. As you can see, nothing is happening. Now, this may take a moment, or it might not work at all. It just depends on what's happening in your particular scene. But eventually, this number should disappear. I'm going to go ahead and build all levels and see if that gets rid of it. Okay, that did it. So there goes all our light maps. They're gone. And now our lights are 100% dynamic, meaning that our lighting is 100% real time. We can change the direction of our lighting. Remember, you have to update the sky because the sky does not understand where everything is all the time. Our sun is in the right spot. And everything is as it should be. See? This is 100% dynamic. Let me get that a little lower to the atmosphere here. This is 100% dynamic now. Let me refresh the sky. Let's match the colors that, oh, that's so bright. Let's match the colors determined by sun position. There we go. And let's get that lighting a little bit more accurate. I'm going to select that light and I'm going to add a little more red to it. All right. And if we hit play, now we are getting some GI with this because that's kind of how it works, but it takes a second for it to kind of spit it up. And you see that our light is fully dynamic, our shadow is 100% dynamic, and everything is lit up for a fully movable light scene. We are getting some reflections down there. Let's grab our sphere capture actor. But you see we do get some better results with our sphere reflection capture. See? But it's not that, it isn't that much different, right? We get a pretty decent result. We've got all of our lights in the scene. Let me go ahead and select my exponential height fog and change the inner scattering color to a little bit more like a refresh color, maybe like that. There we go, purple. Kind of add a little bit of that contrast, that kind of magical contrast. And you get the idea. This is already set up for movable. That's how fast it is. Now, if I'm working on a project and I'm trying to get a scenario where I'm going to know that I'm going to be using stationary lighting, I'm going to light my scene using fully movable lighting. Once I have my lighting set up the way that I want it to be, I will then change my lighting scenario, and then I will do a bake, and then I will check my results. How fast was that? I mean, ignore the weird flickering. That's just normal from this particular water. But you see that we get some pretty good results during actual play. Pretty slick, right? So there's a few things that need to be worried about whenever you're doing real-time lighting. It's very few and far between in any particular project that you would do 100% real-time lighting with no baked lights. What this means is there's going to be a need for some stationary lights in a scene. It's just the way that it is. Stationary lights can be dynamic on moving objects. Let me bring a stationary light in. I'll do this as a point light. Now this is brought in as a stationary light. There is sometimes a need for stationary lights in environments, especially if we need more light in a certain area, but the overall environment is lit correctly, right? This is where you see in a lot of game scenes where randomly there will be an area kind of lit up, but no discernible reason for extra light to be there. That's what is happening. You're using a baked light to add more light to an area. Games are typically, at least before Lumen, are a combination of both baked light and real-time light. Yes, we have a real-time dynamic light, and if we have a programmer, we can program a day light system where as time passes, it can get really, really nice throughout the day. It can be very, very cool, and you tie that directional light, and then it changes the time of day, and you get some really, really cool results. Awesome, great, good job. But in reality, most games have a combination of dynamic and dynamic meaning real time, and stationary or stationary static baked lights, right? That's just kind of the way that it is. Like for example, I'm going to leave that stationary light there. I'm not going to do a bake on it just yet. I'm going to run the character over here, and we see that there might be maybe an item or something we can pick up that's going to be lit up. And you see, yes, there is a shadow, and it does cast a shadow, but we can, for example, cast no shadow. I don't know why you'd want to disable Effects World, but if we cast no shadow on that, which means that it's not casting a dynamic shadow. Now, this light is set up to stationary, but it's not making light maps because that we force no pre-computed shadows to on. But we see how something like this can be incredibly useful for designing areas that should hold player interest, right? That's one of the things that you want to learn about when you're using a combination. In UE4, and there's plenty of content examples out there like Sun Temple, if you download Sun Temple from the Learn tab, that is using a combination of real-time and baked lighting. Because most games use a combination of both. The only reason why anyone, I think, would really want a full real-time scenario that is not using Lumen is because they're doing a tech demo, and the high-performance lighting of that can look and work very, very well. That's just kind of the secret of how that looks and how that works. In particular, when you have a scene that needs to have super accurate dynamic shadow bounces. I don't really see the need for that because I think most games utilize the cost-saving effects of a baked light and the real-time effect of a real-time shadow and light, but your mileage may vary. Let's go ahead and talk very quickly about stationary lights get treated as movable, though, for point's sake. I'm going to go ahead and just, I'm going to have this light selected, and I'm going to make a bunch of these. It might not be angry because it's not all lights are being treated as pre-computed. Let me actually change that. See if I can get it to work here. It might not give me an error. It might. It just depends on the environment. They might be able to handle more. Okay. Let me actually move a picture of it. If you ever get this scenario, does everybody see what's happening there? This is probably because this project got started as we started with the forced no pre-computed lighting, so everything is being treated at real time. That's totally fine. This is what happens sometimes. In a scenario where you have multiple stationary lights, and it could be because they're not casting shadows. Let me see if I can get this actually happen on screen, guys. They've changed a few things in UE5 where this doesn't become a problem as much. there it is. So it'll either look like that or look like this. What this means is that the Unreal Engine's like, whoa, 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 we have too many lights here. There's so many lights that we can't actually fit all the math into this area. Yeah, that light with the red X, I'm just going to set it to movable. It doesn't mean that the light isn't being calculated, because it's very clear that that light is emitting light. See, that light is emitting light. But it's only emitting light because it's being treated as movable. It's marked as stationary still. It's trying to be a stationary light, but there's too many stationary lights next to each other. I've seen a scenario where plenty of students are like, wait, why can't I add more stationary lights to this particular area? I need more light. Just make a bigger light. Increase the intensity, increase the radius, increase the attenuation radius, source radius, do something else, change the light type. But if you see a red X either on it like that, if you see a red X on an asset like that, or it looks like this, in UE4 it looked like this, what that means is not that that light isn't being calculated. It means that that light is being treated as movable, because it cannot fit the math for the shadows into itself because there's too many lights next to it. You will only ever see this with stationary lights. Static lights don't care because they don't cast a dynamic light, so they're like, whatever, more light. Movable lights, you won't see that because they cast a dynamic light. They don't care. Alright, let's move on to the next thing that I wanted to talk about. Let's make sure I'm talking about the right things here. Okay, we talked about real-time lighting. Oh, yes, DFAO. Let's talk about DFAO. So we've got our lighting set up back for some pre-computed lighting, and we have our fully real-time lights. Let's make sure there's a set to movable. Yep, they're both set to movable. They're fully movable. They're good to go. Let's talk about DFAO. Let's see if I can actually show it. Visualize. Go to Show, Visualize, Distance Field Ambient Occlusion. Now, what distance field ambient occlusion does is it creates a scenario where objects have their own self-shadowing baked in and factored into the illumination of the objects around them. If you are on UE5, this is on by default. Like I said, what this is it calculates how your lighting is going to look when you are in a scenario with objects and multiple objects being next to each other. Distance field ambient occlusion is what this effect is ultimately called. And it works really, really well for adding extra detail to your scenes. That's more or less how it works. UE5 has this turned on by default. If you are in UE4 and you're not seeing this, remember I went to Show, Visualize, Distance field ambient occlusion. It needs to be turned on. If your machine is using onboard graphics, meaning if you are using an Intel graphics set or if you're using a mobile graphics set that doesn't necessarily have DirectX plugged into it, if you don't have the hardware that can run distance field ambient occlusion, you will not see this. It will show up as blank. I can't fix that because at that point it is a limitation of, not the card, but a limitation of the hardware and architecture of your current system. If you have a graphics card from AMD or ATI, you probably have DirectX. If you have DirectX, you probably have access to DFAO. If you have DFAO on, it will look like this. If you don't, it will look like nothing. If you can't enable it, that's okay. All this does is it allows Lumen to work better, and it allows all other lighting scenarios to work better because it adds an extra layer of processing. When would you want to have DFAO? When you have large areas with a lot of detail like this. When wouldn't you want DFAO? If you're working on a mobile game that is on a phone that can't handle everything. But one of the biggest markets for games right now is China and India. And there's no reason to be calculating DFAO if you're using sprites. Does that make sense? Right? let's talk about how, we talked about how to enable it. Let's talk about how to modulate it. If we go into Skylight, DFAO is part of Skylight, and we scroll down, we get our distance field ambient occlusion here. And this controls what our occlusion is supposed to look like. This is what's going to change a lot of our overall ability to see what's happening in the scene. Let's go ahead and go actually back to show, visualize, and disable DFAO visualization so we can get back into our visualizing mode. I'm going to look at this in a more fun way. Go ahead and select your Skylight, and now go ahead and go into DFAO. It's going to be under Skylight, DFAO, Distance Field Ambient Occlusion, and let's select the occlusion tint, and let's set something really funny, like hot pink. And go ahead and hit OK. It's very clear that we can now very easily see how the DFAO is creating kind of like this fake global illumination where assets are lit by the color of their shadows. That's wild, isn't it? This is also kind of the intro to cell shading, if that's your thing. It's actually a lot easier to do cell shading than do this. So you see how the DFAO affects this particular scene. We're getting into some more advanced lighting concepts here. This works in particular for movable lighting, but I believe it also works for stationary as well. As long as you have DFAO enabled at the engine level. If you're using UE5, all your projects are going to have DFAO enabled. If you're using UE4, you're going to have to enable it manually. And you can change a few things about this. Like, for example, you can change the distance, which affects the overall, like, so that's back to default. I don't believe you can set like an obscene number. You can, but you don't get a whole lot of value out of it. Another 0 on it. So, if you're in UE4, you will probably be able to get this to cast really far. In UE5, they have rewritten the DFAO completely to only be useful very, very close. So, if you're in UE4, you should be able to cast DFAO very far. If you're in UE5, yours is going to look like mine, because we're in UE5. We have the occlusion contrast, which changes the occlusion contrast between light and dark areas. You can see you can create more contrast and also add more contrast if you feel like it's necessary. This is kind of how they made the graphics in No More Heroes. They had large gradients between light and dark. We can set the occlusion exponent as well. Exponent being the overall power that it's getting from the surrounding area. We can set a minimum max occlusion here. Setting a higher minimum occlusion means that we set a lower value to start with, meaning everything below that value gets chopped off and then we start at a higher number. And we don't want to worry about OCM minimum. Leave it on minimum. Multiply almost never works very well. Let's see if it gives an effect. Minimum tends to work a little bit better. And of course you get RGB of the occlusion tint. We can always set the factor default. So you have some control over what this effect is going to do in your scene. And so if we are designing a scene that's starting to get maybe later in the day, we might want to think about maybe changing the DFAO so that we have a light that might speak to our scene a little bit better. Maybe a little bit more blue back into the scene, or a little bit more, whenever I have red, I just generally like to have a little bit of purple in the scene because it adds a little bit of an exponent that looks a little bit more like, oh, yes, the sun is super hot, but we're getting later in the day and it's kind of going away. And you see how that effect kind of propagates to just kind of everything in the scene. You see that it has like a very nice coolness to it, kind of indicating, oh, it's sunset as opposed to sunrise, so to speak. Little things you can manipulate like that. So that's DFAO. I'm going to set this back to default black so we can go back to manipulating this particular scene here. Okay. Alright. What else do I want to cover? So that's distance field ambient occlusion. Do I want to talk about distance field shadows? I talked about them briefly in the previous demo, but I want to talk about them again anyways. go ahead and select your directional light. And if we scroll down, we have access to our distance field shadows. This again controls the overall effect of what is happening with shadows at a distance. Remember, this also makes elements come back into being. This is what I showed you guys the other day with the shadow frustums, where the shadow distance, you might go so far where you can't see certain shadows appear. This is where you would want to tweak those values so that your shadows do appear there and get something a little bit nicer. It's back to default. So you see kind of how the cutoff is happening from our lights. We can add more shadows and we can kind of remove them. We can always add more value to these numbers as well. Again, the higher that you go, the more expensive things become. And of course, our cascaded shadow maps as well. We see how we can kind of control that distance as well. So our dynamic shadow distance, we can add another, let's throw another 0 in there. Those are getting too small to actually see, but we can continue to add more value. We've shoved things out of the buffer. That's why that did that. Sorry. Let's go back to the default. There we go. So you can absolutely change the distance of those shadows and bounces or whatnot. I'll talk about that here in a little bit when we're talking about the advanced kind of lighting solutions and scenarios. What else do I want to cover here? Let's make sure I'm covering everything that I want to. So again, all of these effects generally work together. Cascaded shadow maps, our distance field shadows affect kind of what's happening in the distance. Come back that up a little more and reset a few things here. So the combination of the cascaded shadow maps, let's go ahead and we're using a movable light, so that's not going to be accessible to us for now. Does everybody see how the dynamic distance, we already have a dynamic shadow, so this is not going to affect our shadow at all. Our light would need to be switched over to stationary in order for that setting to be available. That's for the shadow distance. So because we are fully movable, the only thing that we can control is kind of how our shadows bake into the scene using the cascaded shadow maps, which work within reason. You see that we are getting some kind of result from them. And that's the movable light distance. So on and so forth. But when you have fully movable lights, you don't really have a bunch of cascaded shadows, but the simulation still works, at least for this particular slider, because it talks about how the value works for a movable light. Cool. All right. Let's see. Did I cover everything I needed to? I don't really need to do some changes. We talked about distance field shadows. Again, that's probably incorrect lighting over there. That's probably more correct right there. Right there, to have that kind of penumbra over there. Add a little bit of trace. Change the offset a little bit so that we can get some of that cresting back in. Now you guys might be wondering what's going on with this over here. It's all bright and shiny. Just ignore it. It's a problem with the demo that happens all the time. This particular landscape that they use in this scene does not like, for whatever reason, it does not like having light placed on it at that angle. If I was correcting this for another artist, I would probably put something there to hide that as opposed to move it, because we don't really need that for the scene. But in this particular case, the texture is what's causing the issue. We'll talk about that in the future. But this is more or less set up the way that we want it to be. This looks pretty good. Now, bear in mind that I haven't done like a full-on lighting scenario yet. I'll probably save that for the demo on Thursday. Generally speaking, like I talked about, I disable the adaptive eye. We're not talking about the adaptive eye in this particular demo, mostly because I already know the results that I'm kind of expecting from futzing around the way that I do. But generally speaking, you should always disable the adaptive eye before you do any kind of long-term lighting. For me, it's a little different. For you guys, definitely disable it. But I'll do a full walkthrough in a little bit. I'll do a fast one as well. Let's see, we talked about distant fuel chat, we've polished. Okay, let's go ahead and I'm going to save now. Cool, cool. And what's my time on this? Like 40 minutes? 30 minutes. All right. Let's go ahead and jump into something a little bit different. I'm going to keep this movable setup, but let's talk about nighttime. I'm going to set up a nighttime scene for us. So I'm going to go ahead and select CS Moveable, and I'm going to duplicate it. And instead of calling it CS Moveable 1, F2, I'm going to call it CS Moveable Night. Alright, so I've got my CS Moveable, I'm still in the old map. I'm going to open up my CS Moveable Night map. Awesome. Verify that you are on the correct map by checking the top left tabs. And then we can continue working from the movable night. So, I showed you guys how to do day. I showed you guys how a baked lighting scenario works. I showed you guys what cascaded shadow maps do. I showed you guys what the DFAO does. I showed you guys how area shadows work. I showed you guys how movable lighting works, the sphere capture actor, and I've showed you how the light mass importance volume works with baked lighting. I've covered everything that I need to in the sections that I've needed to. Let's talk about simulating darkness in a game environment. One of the most important things that you can learn about lighting is that games lighting and realistic lighting don't necessarily line up. Lighting in games is BS. Lighting in the real world is beautiful. It works on a mathematical scale. It's great. It's elegant. Nature's weird. Nature's crazy. Nature does some crazy things. When it comes to lighting in games for darkness, there are a lot of things you have to keep in mind when you actually create light for games. Ultimately, unless you're making a game that relies on a character absolutely needing light as part of the mechanic, night is simulated. Just like in your favorite TV shows that happen at night, night is always just blue. Light in games, night in games at least, is not the absence of light, but it's the correct color grading and placement of lighting solutions in order for the light to be or to adhere to the correct amount of lighting in the scene. Just to set up our scenario, let's make sure that we have 0 light maps and that our forced pre-computed lighting is off. And we're going to develop a night scene. And we're going to create the idea of the essence of evening by creating light that fulfills that purpose. First and foremost, let's go ahead and select a directional light. And I'm going to go ahead and press E. And I'm going to rotate this up so that we're facing basically as close to upwards as possible. I'm going to go to the details panel, and I'm going to check to see if its rotation is correct here. Oh, don't want the location to be moved. Let's see if the rotation is okay. My directional light, it'll be fine. Let me make sure that I'm in the right axes here. Okay, I'm going to zero out the other two. I'm going to zero out all of this actually, and that way I can get a direct 100 degree or 90 degrees straight from underneath up. Okay, so I'm pointing from underneath the world right now. In fact, you know what? Let's just do this differently. I don't want to set this up this way in order to confuse people. Let's do it the old-fashioned way so that everybody can see what I'm doing. I just had divine inspiration where it's like, wait, I shouldn't do it this way because students might get confused. Let's delete all of our lights. All right. We've got our fog actor here. I'm going to set this back to its defaults here. And I'm going to reduce its density so that we can kind of get some light. Actually, you know what? Let's get rid of our exponential height fog as well. So as you can see, our scene is going to be unable to be updated. Everything is 100% fully dark. And we are getting some light from the atmosphere of the sky because that's just kind of how it works. But we're unable to see anything. Let's go ahead and start by dragging in a new directional light. And we're just going to rotate that to where it's pointing up at 100, or it's pointing straight up at us. Just get it as close as possible. It doesn't have to be 90 degrees, but just get it close. This is like some spooky, like, Are You Afraid of the Dark kind of looking stuff. And in fact, because we have our light in here, let's go ahead and change our lumen value to our directional light, and we'll set this to 0. Okay. Let's go ahead and connect our sky to our directional light. Click on the sky. Select your directional light actor from the directional light actor tab. Okay, that's cool. If that doesn't happen immediately, make sure you have colors determined by sun position turned on immediately. Okay, so we have a night sky, but we have nothing else. Okay, that's fair. So what we've done here is we've correctly associated the sky in the direction of the sky to what we want the environment to look like. At least the sky, right? This isn't giving us anything useful. What this is doing is it's fundamentally just giving us an environment that kind of mimics what we're supposed to be doing, but is not actually what we want to be doing. Okay, so this is a little bit not helpful, but that's totally fine for now. Let's go ahead and bring in a skylight now. And watch what's going to happen. We'll grab our sky, we'll grab our lights, we'll bring in our skylight. And I'm going to set this down to a stupidly low value of like 0.1. Alright, so we have something. Something is definitely happening. We're seeing some stuff kind of at the edges. Let's see if it's coming up on Discord here, or Simiana. So you guys can see that we are getting something that comes up on the edges. But if we hit play, it's still really, really dark. We can't see anything. That's okay. We can get that fixed here. Let's also go ahead and grab our exponential height fog. It's going to be in the visual effects. And let's grab an exponential height fog. And we'll bring this into the scene. Okay. That's a lot of exponential height fog. Let's go ahead and set that density to 0. And now we have everything in place here that we need in order to start modulating our scene so that our scene has the ability to look like a nighttime scene. I'm going to go ahead and select my fog, and I'm going to set something real small. 0.0005. Alright, and you see the adaptive eye is trying to assist us. This is where the adaptive eye can become a problem, right? You see that when the adaptive eye is trying to fix some of the issues, this is where you can have it set up a little bit differently if you want. I'll show you guys how to speed that up. But we've got some amount of lighting in the scene. Okay, maybe we need something even smaller than that. Let's throw another 0 in there, throw a 5 in there. Okay. So that's starting to look a little bit more like what we want. Come on, adaptive eye, give me something that I can see. Okay, that's giving us something that we want. We can also change a few elements of the fog in order to give us something that is more akin to what we want. Let's do... That's fine right there. And I'm just going to crank up my start distance here just so that I have this starting further away from the character. I'm going to actually set this to like 6,000. Okay, that's going to be fine. Back it up from there. 5,500. 800, 6,000. 6,000 will be fine. That's going to be a good start distance. Got our opacity set up. I'm not worried about I've got the fall off set up. I've got the intensity set up. Okay. Let's go ahead and this is where you can muck around with it to get something that looks pretty decent. We don't have to worry about the sky. Well, all we need to do now is manipulate the fog density to where we get something that looks good for our particular scene. And it's going to be like a very, very small number. Alright, so we got something that looks okay. Cool. You can use whatever numbers you guys want, but I'm not going to worry too much about what is happening in our particular scene. I'm more interested in making sure that we can see everything that we need before we actually get into fixing some of our lighting problems. As you can see, we can't really see all that well. Let's go ahead and go to the skylight here, and we're just going to start bumping this a little bit until we can actually see a little bit of the environment. Now, I should probably note that both these lights should be set to movable, and make sure that your fog is also set to movable. Oh, that's my player start. It's going to be movable by default. Make sure your lights are set to movable so that we don't have to do any bakes to check to see if everything's working okay. Let's go ahead now and bump the intensity of our skylight. Oh no! 0.2, 0.3, 0.4. Okay. As you can see, there's still inherently a lot of fog that is in the scene. Let's back that off a significant amount. Okay, so we can kind of see that we're getting some stuff. If you want to turn off specific lights to see how much they are investing, I'm going to select all my lights here because I forgot that I added new lights. I'm going to go ahead and put them into the lights effects folder so that they're all together. And let's see what the skylight is having, the effect the skylight is having. Okay, so the skylight is having a very profound effect. I'm going to add a filter on it so that we're getting a slightly kind of spooky color. And I'll see if I can bump the power a little bit to give me something that looks a little bit better. Let's see, 0.85. 2. Let's see. It's a little bit too purpley. I might want to go back to, you know what, I'm going to set it back to white. Set it back to white. And then I am going to kind of decrease its overall value by about 50%. That's good. And then I'm going to set the intensity scale to something that I think is going to work for nighttime. And then at that point, if you want to add a color or 2 or 3 to kind of give it a little bit more pizzazz, that's where it kind of works out a little better. Okay, so it's still very dark. Give that a sec. Give the adaptive eye a sec to kind of figure out what it's doing for us. Okay. Now, this is simulating something like a full dark kind of scenario. This is not ideal for games development because we can't actually see what's going on. So we want to add enough light. Let's add some light in here and see what this looks like. To where you can kind of see what the effect is happening, or what kind of effect is happening. Okay, so our biggest violators here are probably on top of the skylight, a combination of effects from the skylight and the exponential height fog. We can always go and just manipulate the saturation of certain things, but also the sky isn't really doing us any favors. So let's go ahead and play around a little bit with the sky to see if we can get it to do something a little bit more sky-like. For example, Let's go ahead. I'm going to turn the sun brightness to 0. Even though there's no sun in the sky, we don't need it. I'm going to reduce the opacity of the clouds. And then I'm going to turn up the stars. No, I'm not. The adaptive eye needs to... This is where you can have anti-stars, by the way. Let's add a little bit of a boost to the power of the stars. That's totally fine. Let's turn the cloud speed way down. Alright, so we still have a lot of problems here because obviously we're getting into a scenario where we're not able to affect the full color of the sky and really have control. Why? Because unfortunately right now the thing that has the most control is colors determined by sun position. Let's go ahead and see if we can solve that. Let's go ahead and change some of these zenith colors. Oops. Sorry about that, guys. Let's change some of these zenith colors so we can get a better effect to what we want sky-wise. Same thing, I'm just going to desaturate the sky and get rid of the clouds this way, or get them really, really dark. And then our overall color, change some of that. We can see our exponential height fog is having an even more profound effect here. See? Alright, so we're messing around with it so we have something a little bit better. Let's reduce the horizon. Cool. And let's bump up the stars a little bit. Bring back some of those clouds. Hit play and have a look. Okay, that is indeed pretty dark. You can see kind of how the adaptive eye is giving us the incorrect impression of what is happening in this particular scene. But you see that the scene is fairly dark still. Okay, so this is where we have to make a decision now. Do we want our scene to be dark, kind of like, I don't know, I can't think of too many games that use full dark. I know Skyrim uses some mods to kind of create full dark. Or do we want to create the impression of darkness? In order to create the impression of darkness, all we need to do to get more power here is let's reset our skylight color. Let me undo that. I'm going to reset the light color for the skylight. And we're just going to set kind of a weak number and see what this looks like. Sometimes you need a little bit more power, so let's add a little bit more. Give that a second to kind of boost up its overall power. You see how the adaptive eye is very difficult to work with sometimes. I would honestly, for a night scene, I would clamp it and set it so that it doesn't give us this effect. But this effect is only happening because, again, the adaptive eye is trying to adapt to an environment that is just supposed to be dark as a whole. So that's where the adaptive eye becomes very problematic, right? But you can see that this is about what I want it if I let the adaptive eye kind of do its thing. This is about how dark I want it to be. I can also disable the adaptive eye, but I'm not going to. I think this will be okay. Yeah, that's about right. Let me go ahead and add some actual real lights in here. I'm going to add a light, and I'm at a point light here. And I'm just going to kind of move this up into this sconce here. Now, let me explain kind of what's happening here. Let me go ahead and change the color of this light so we can see it a little bit better. Something a little bit more orangey. Let me increase that fall off. Let me add another one, because everybody needs a friend, right? And I'm going to disable this one for now. Actually, you know what? I'll hit OK on that. Wait, did I not copy it? I hate when I do that. Hold on, Alt. There we go. Now, because we're doing movable lights, let's go ahead and make sure these are set up to movable so that we don't have to rebuild. Okay. And then I'm going to select my friend light here. These are my lights, so I'm going to move them into my light effects folder. Cool. And my friend light here is going to be disabled for now. So what I'm going to do is I'm going to turn off the visibility for now. And we're going to take a look at kind of what's happening here. So let me hit play here. So now we have some more light in the scene, and that should in some ways fix some of our adaptive eye problems, because now we have another light that we're grading against. Adding more real point lights actually corrects some of the issue for the adaptive eye. Nifty, right? See how when we move away from that, suddenly we ramp down into a bad adaptive eye? But this is where it becomes important to understand what the adaptive eye is doing. Dark Souls doesn't really have an adaptive eye, although it simulates it in some places. Different games are going to approach it in different ways. I'm going to leave the adaptive eye on, and then we'll talk about it as a demo in the intermediate class, because this is just a starting lighting class, guys. The intermediate class is going to talk more about backing up some of the stuff that we've talked about in this particular thing, like especially volumetrics. I don't want to talk about volumetrics too badly just yet until we get there. This is just supposed to be lighting for this week. So you see how powerful that light is now, because we've increased the fall off for it, and how that light is having an effect. In fact, I want to make sure that this secondary light isn't causing any issues. Does it play? The adaptive eye takes a second for it to load in, but you see how that light really affects the environment that we're looking at. Okay, let's take a look at what's happening here. This point light is currently set into this sconce here. Oh, I've got the wrong light selected. This point light is currently set into the sconce, and I'm going to turn this thing off so I can center it a little better. And what is happening is we can see very easily that the bottom of the sconce is occluding light. We see that the light is blocked here. And we see that we have a nighttime sky and that we have some amount of custom work to it. Now, it really depends on what you're doing with it. I'll get back to light in a sec. But if you're fine with the sky looking like this, or if you're fine with the color determined by sun position, depending on what you want, I showed you guys how you can get a better looking sky. I personally like this sky a little better aesthetically, but this one is like spooky too if you want your colors determined by sun position. So it's up to you to decide how that's going to work for you. I personally like to have more control of it. When you have a, let's go back to point light. When you have a point light, let's turn the exponential high plug back on. When you have a point light, it is going to obey geometry next to it in order to give you a more accurate lighting representation. Yep, it will. If we inset, however, watch what happens to this light. Where's the bottom of our sconce? We're inside the light. What's going on? Light that is inside of an object, if a light is set inside of an object, it will at some point stop rendering portions of that object in order for the light to go through it. So for example, if I wanted this to have super accurate lighting, obviously the bottom of the sconce would have to be casting some amount of shadow, like so. However, that might not always be the best way to get the best kind of lighting in a game, because you can see it's casting a weird shadow. It doesn't look very strong. It looks kind of weird. It just depends on what you want. Sometimes the best solution is to deal with a little bit of something like this in order to get the best solution for what the light should look like. And then you solve problems like that hard line shadow right there. You'd probably move the light a little bit, or move the light around it, or add a light underneath and on top to kind of hide that effect. It really just depends on what you're doing light-wise in order to get that effect to fill itself out. In this particular case, I have both a light and, in fact, I can actually make them show in game by actor hidden in game. You know what? No, don't want it hidden in game. I just want it shown. So as you can see, as you add more light and then make decisions on how those light positions are going to affect the world as a whole, you can make choices on how the overall effect is going to affect your game world, so on and so forth. So let's say I have this light set up, and maybe I do want more accurate light. Maybe what I'm going to do is I'm going to reduce the distance of both of those lights. Reduce the distance of both of those lights so they get a little bit smaller. Make sure we get some overlap on this. White light, skylight. And then I'm going to make a decision on how that lighting looks based on what is happening with the shadows in the game. Maybe there's not enough light in this particular area, so maybe what I'm going to do, again, if I'm doing this is fully dynamic, so again, it's going to be relatively expensive because it's fully dynamic. But if I was designing a scenario where this light would be useful in the game, what I would do is probably grab a point light here. Let's turn off the shadows for that. Doesn't cast any shadows. I'm going to grab a color of the scene here. Cool. Oh, cancel the operation because I didn't set that up. Add a little more candle power right there. Mess with the attenuation radius a little bit to get something a little more natural. Play. Funny how that works, doesn't it? It's not necessarily always about putting a light in the right spot. It's about putting the right amount of lights in the right place so that you get the best result that you're looking for. Granted, not the prettiest approach, but it still works by and large. Making sure that I'm casting the correct lights. Do I want this one? Yeah, this is. You notice that this was not casting a shadow. Let me actually make sure that I'm in the right location here. Play from here. Come on, Adaptiveye, help me out. Or did I fall through the world? Yes, I did. So I got a little lost there. No worries. I have no idea where I am. You hit Alt-3 to turn the lights back on, or for me, we'll do that, and then we'll do that play from here. Cool. Double check my notes to make sure I'm covering everything here. Let me pause for a moment, make sure I'm capturing all my notes here. I'm back. One last point that I want to make. Now again, this light isn't casting any dynamic shadows, and these lights are too far away to really cast a really good dynamic shadow. So it's sometimes a push and a pull to kind of get everything working correctly, right? So if you wanted something like that, a little bit more well placed, play from here. So now we have a dynamic shadow kind of in the right spot. Ignore the fact that his feet float on the stairs. See, we have a lot of light here in this area now, so this works okay. And then as we go into areas like this that need to be lit and or we need to control the adaptive eye, that becomes important. Now, because I've been lighting the scene with adaptive eye off, our results might not look as good as we expect. But let's go ahead and try to fix it, and then we can go ahead and wrap this particular demo up. And then I'm going to do one more demo. It's going to be about 30 minutes for Lumen. Okay? Let me go ahead and create one volume, and that'll be my post-process volume. Go over here. And then I'm going to go immediately into Infinite Extents Unbound. And then I'm going to go into Exposure, because that's the stuff that people pay you with, right? Exposure. Let's do Alt-4 to turn that on. Let's go into Exposure. And then I'm going to crank the speed on the adaptive eye. And then let's see what it looks like with the adaptive eye cranked. You see how fast that kind of dips in and out. Let's go ahead and set the values here. I'm going to 1 and 1 to disable it. Now obviously it's going to look terrible because we lit this scenario using the adaptive eye off. This is what the scene looks like without our adaptive eye. And why I'm very critical, and I think it's very important to make sure that, oh, didn't mean to do that. Hitting the bench here. That if you light scenes, they should be lit with the adaptive eye turned off initially. The adaptive eye should be an effect that is added afterwards to make things look cool and to give us that effect of going in and out of the scene. But I'm not going to grade anyone down if they lit their scene and it looks good. You just at this point need to do a little bit more work to realign what the brightness of your eye is supposed to look like. In order to get that effect working the best, I hate to admit that there's a little bit of work involved to making it kind of do its business here. So I'm going to disable those. Actually, I'm going to re-enable them and set them back to default. And let's see if I can remember this correctly, because usually I don't mess around with this too much. Max brightness sets up how squinty your eye gets when it's in light. Min brightness sets up how wide your eye gets. The problem is that you don't want to set up values that are too negative or too positive. You don't want to set up a negative brightness. And typically speaking, most games do not have enough brightness to warrant this kind of range. So what I'm going to do is I'm going to set this up to 0.04, I think. Let's see if I get more. Less is more, maybe? 0.03. 0.01. So I'm doing a little bit of futzing around here to get this working. 0.025. A little brighter. Okay. It's a little too bright still. But do you see those ranges that we have to kind of play around with in order to get like the correct exposure for the adaptive eye? Let's set this to like 2. And let's hit play. See what I guess the result looks for. Again, this is more advanced lighting. So you see our adaptive eye is giving us some results. but we're still dipping too dark into certain areas. This is the kind of stuff that you run into when you light without understanding what the adaptive eye is supposed to do to your scene. In all actuality, in this particular, for a particular scene like this, I would probably right, this sets up how wide the eye gets here, so let's test this out. This is not a lot of light in the scene. This is kind of the issues that we're kind of dealing with here. So, default. How annoying do I want to be about this? Yeah, this is where it gets kind of complex, guys. You see that I'm visualizing the HDR. This is more acceptable. It's easier to, at this point, go in and tweak the skylight and tweak the other lights in the scene than it is to actually try to get the light to work in this particular range. This is what is happening in our scene. You see how the eye is adapting to what is happening in the scene. There's a lot of light in this particular area. You see that the light is that blue line here, and our adaptive eye range is representative of the green. That's what the adaptive eye is doing. In some areas, we're getting really, really high light, and in other areas, we're not. So expanding this particular range also expands that maximum low-level darkness that we can experience. You guys don't have to do this. I'm not going to make you do this. See if that gives us a better result. It's not even going to be discernible, which is really annoying. There you go. Did you see how that kind of worked out to be very comfortable? That transition was relatively comfortable. Yeah, guys, this is not my favorite part to teach because this is the intermediate class. Don't worry so much about exposure. Worry more about making sure that your night looks like a nighttime in a game. If you did this while having the adaptive eye on, it's fine. I'm not the police. I'm not going to yell at you. Just get it something close to this, okay? You'll see as this is part of your homework, you should be fine. All right, so in order for this to work, I'm going to create a brand new project with Lumen started, and I'm not going to turn any of the Lumen stuff off. It's going to take a bit to set up, but I will see you guys very quickly in the next one for a Lumen demo. All right? And then we'll talk about kind of what's set up. In fact, it's already the default in UE4, or excuse me, UE5, not in UE4. So if you're in UE4, watch the next video because it's still important. I'm going to disable my camera for next video, but in UE5, if you're in UE5, you might glean something from this. So I'll see you guys in the next video.